Okay, in this video we're going to look at solving a rational inequality. So here's the inequality we're going to solve. What inequality means is an inequality symbol, so a greater than, less than, greater than or equal to, or less than or equal to symbol, similar to an equation. It's rational because there's a rational term. Now, we did polynomial inequalities, and if you remember, they're very similar to polynomial equations. Rational inequalities are similar to rational equations, except at the end. And one key difference is if you thought about this as an equation, if this were an equal to sign, then the way most people would do it is to get rid of the denominator. You can't do that in an inequality, and the reason is you have to think about why you got rid of the denominator. So the way you were able to get rid of the denominator is multiplying both sides of the equation by x minus 3. Right? I put x minus 3 here and x minus 3 here, and then I canceled these out, and then 0 times x minus 3 is 0, so I was just left with x plus 2 greater than or equal to 0. That doesn't work in this case, and the reason it doesn't work is if you remember when you multiply an inequality by a number. So remember when we have an inequality, let's say it was x over 2 equal when it's an equation. Sorry. No, when it's an inequality. If I multiply both sides of this inequality by 2, that's allowed. And then I would have x is bigger than 14. But if it was x over negative 2 bigger than 7, then when you multiply both sides by negative 2, you have to do something. And what you have to do is switch the direction of the inequality. So when you multiply both sides of an inequality by a number, by a negative number, you have to switch the direction. Well, the question is, if I was to multiply both sides of this inequality by x minus 3, would I have to switch the sign? And the problem is, sometimes you would, sometimes you wouldn't. It would depend on the value of x, right? If x was a large number bigger than 3, like 10, then this is a positive quantity. If x is a smaller number, like 0, then this 0 minus 3, that's a negative number, and you would switch it. So we don't know what we should do. So the answer is you can't multiply both sides of the inequality by 0. What you have to do is sort of set up a table. So you look at the roots of the numerator. So the roots are when does the numerator equal 0, which would be at negative 2, and the denominator. So that would be at x equals 3. So I have two roots, negative 2 and 3. So now I set up an interval table. So the interval table is going to extend from minus infinity to minus 3, the first root, minus 3 to 2, and 2 to infinity. And now I'm going to look at each factor, both on the numerator and the denominator. And I'm just going to figure out if the factor is positive or negative in each interval. So if x was a number less than negative 3, so try negative 10. If you sub that in, you get a negative. If you sub it into this factor, you'd also get a negative. Between minus 3 and 2, so you get a 0. This one would be positive, and this one would be negative. And if you took a number bigger than 2, so like 10, both would be positive. Both would be positive. Now, we're looking at the factor or the term x plus 2 divided by x minus 3. So that's this divided by this. Well, in this interval, if you divide two negatives, you get a positive. Here, if you divide a positive by a negative, you get a negative. And here, if you divide two positives, you get a positive. So we were looking when is it bigger than or equal to 0, which means positive. So these are your two solutions. So therefore, the two intervals. So therefore, x is an element of minus infinity to 3, and then you include 2 to infinity. So just a comment about the brackets I'm using here. So notice this is greater than or equal to, so I have to use the square brackets. So that's why on the 2 I have a square bracket. Now on the 3 I don't. And the reason I don't is 3 was the restriction. 3 was what would make the denominator 0, so x cannot be equal to 3, so you won't include that in your interval.